We've looked at if, else if conditional structures in C#, where each fork of our conditional structure is looking at a Boolean expression. So maybe it's condition 1, condition 2, condition 3, and so forth, and we could literally have tens, if not hundreds, of conditions here. And only one of these forks would execute. So if this one is true, if condition 1 is true, it doesn't matter what condition 2 or condition 3 or condition 4 and so forth is, because it will never evaluate those. Once it finds a true fork, that's the code that's executed. Well, if these conditions, condition 1, condition 2, condition 3, are all comparing the same object. Maybe we're comparing the value of a variable named x. And maybe our first condition is if x equals 1, we want to do something. And this one is if x equals 2, we want to do something else. If x equals 3, we want to do something else. So if all these are comparing the same object in the conditions, there's actually a better way to write this, and that's using a switch structure. In the switch structure, we draw the flowchart this way. There'd be a value that we're examining, and then we have multiple pathways coming out of that Boolean expression. And so we might have value 1, value 2, value 3, value 4, value 5, and so forth. And one of these forks will be executed based on which one is true, starting from the left to the right. So if value 1 is equivalent to the object being examined, or the variable being examined, then that fork would execute, the others would not. In terms of writing that code, we use the keyword switch, and in parentheses we put the object that's being evaluated. Might be a variable name such as x. And then our curly brackets, and then we specify some cases. And so case here be maybe value 1 might be 1. So if x equals 1, we're going to do something. And then after we've done that, we want to specify a break command, which means stop here, don't evaluate anything after this. If value 1 is not a match, then it might look at value 2. Maybe this one is case 2. And so if x equals 2, we would do something there, and again we would break. And we can have as many cases as we need. We just need to conclude with a default. And so the default says, let's do something if none of these cases above match. We're going to do something, and again we need a break command. So that is the syntax for the case structure. And by the way, you might have more than one case together. So maybe we want this code to execute if x is either value 2 or value 3. And we can write it that way with multiple cases together. Let's take a look at an example. I have here a simple calculator with some text boxes. This one is named txtnum1, txtnum2, and then our txt solution. I also have a label here called LBL operation. And this one is just a non-named label. It's got the equal sign. This label is going to be able to change value to reflect which button of operation the user has clicked. So let me just demonstrate this real quick, then we'll come back and look at the code. So I have a value here of 5 plus 2 equals 7. If I change this to a minus sign, I'm told that 5 minus 2 is 3. Multiplication, 5 times 2 is 10. 5 divided by 2 is 2.5. And then of course 5 plus 2 is 7. I can also change these values. So I can say 10, and as soon as I change the value here in the text box, it reflects the updated solution. So again, I can subtract, I can multiply, I can divide. Well, let's take a look at how this is done in this project. So I have 4 buttons here: btn add, btn subtract, btn multiply, and btn divide. And they all respond to a click event named update operation. So there is the click event for the divide, update operation. Here it is for the click. Here's the click event for the addition, and the other two are the same, both update operation. So let's take a look at that code. So on those 4 buttons, we're going to use the sender object. We're going to cast it as a button and put it into XYZ. And so LBL operation, which is this label here, shows the plus sign or the minus or the multiplication X or the division symbol. whatever is reflected on the text of the 4 buttons, which in this case will be represented by XYZ, that's what's going to go into the text box. Okay, so all that's doing here, if we ignore the operations happening, just focus on this little label here between the 2 numbers. There's plus, minus, multiplication, division. Now, that label, LBL operation, also has an event. And the event that we're handling here is the text changed event. So anytime this changes, it's going to execute some code. Let's take a look at that code. So in this code, I have the perform operation method, and I'm setting 2 variables, num1 and num2. And I'm going to put the data that's in those 2 text boxes that the user has entered into num1 and num2 using double.parse. So these are double values. But then I'm going to look at what is the value of LBL operation.text. Well, in this case, if it's a plus sign, we're going to add our 2 numbers together, num1 plus num2, convert that to a string, and display that in our txt solution.text box. And that is this box here. So 5 plus 2 is 7. Else if LBL operation.text is the minus sign, or a dash, we're going to subtract num2 from num1, convert that to a string, and display that in that text solution. If that's not true, let's test to see if LBL operation.text equals the multiplication x. Now I use an x here because that's what most people think of in terms of multiplication. They don't think of the asterisk that we use in code. But if it's an x, we're going to multiply num1 times num2 and put that answer into txt solution.text. If that's not true, let's test to see if LBL operation.text is the division symbol, a slash. In which case we're going to divide num1 by num2, convert that to a string to 2 decimal places, and put that into our txt solution text box. Else, if none of those are true, we're just going to set that txt solution.text to a null value, quote, quote. And that is how we can use an else-if structure to cause that to work. But I'm going to change this to a switch structure because if we look at this, each of these conditionals is looking at the value of LBL operation.text, and we're comparing it to something. And so when our conditions that we're examining are all the same object or the same variable, a switch structure is an ideal way to do this, especially when you have 3 or more forks. So let me switch this over to a switch structure. I'm going to just go through the magic of copy and paste. So here I have replaced the else-if structure with a switch conditional structure. The way we write this is we have the word switch and then in parentheses the object we want to examine. In this case, it's the text that is in LBL operation. Now if the text in that label is equivalent to the plus sign, we have this case structure here. So it's case, the value we're comparing to our variable, or in this case to our text property, and then a colon. So it's always case, the match, colon, and then the code we want to have happen. In this case, we're going to add num1 plus num2, convert it to a string, put that in our text solution, our txt solution text box. If that's not true, we're going to check and see is the case a match to a minus sign. If LBL operation.text equals the minus sign or a hyphen, then we're going to set txt solution text property to num1 minus num2. If neither of those are a match, let's check and see if LBL operation.text is the uppercase x. And if that's the case, we'll multiply the 2 numbers. If that's not the case, we will test the division symbol, the slash. If that's a match to the text property of LBL operation, then we'll divide num1 by num2 and put that in our txt solution. And if none of those are matches, we always need to have this default case. In this case, we'll just put a null string into txt_solution.txt. So I'm going to run this again. I'm just going to change these values here. So let's do 8 and 4. So if we add those together, we get 12. We subtract, we get 4. We multiply, we get 32. We divide, we get 2. And then our plus sign again. 8 plus 4 is 12. Now you'll notice that I'm also, if I make a change in either of the text boxes, it automatically reflects. And let's look at why that is happening. So in our design, these two text boxes in which the user would enter a number, they also have the txt changed event being handled by that perform operation. So if I change the text in this text box or that text box, then this code is also being executed. So we have 3 labels, actually 2 text boxes and a label, all being handled by this perform operation method. When you have multiple cases or multiple comparisons, the switch case structure or switch structure, in my opinion, is much more readable than a whole bunch of if-else-if structures.